am very happy to welcome you to this last session of the Exploration Science Forum. I think it's just been a fabulous meeting, and it's just going to get better right now because we have with us today Alan Stern, who I know needs no introduction to all of you, and so I'm not going to spend a lot of time talking about him right now. I just want to tell you that we are here because of him, because of his vision. The Lunar Science Institute and the Lunar Science Forum started in 2008. And then, as you know, we grew to become CERVI. And so I'd like to take this moment to thank him for that and for all his support all these years. Would you please join me in thanking Alan for starting us? And he's gone through all kinds of personal hardships to be here with us today. I'm sure he's not even going to tell you that, but I can tell you that he's got to be exhausted. And we are very honored to have him with us today. He's going to talk to us about New Horizons, past and the future, a promising future of planetary exploration. So without further ado, I'd like to bring Alan on stage and let you know that at 3:20 sharp, we have to get him out of here to get him to San Francisco Airport on time. So he's going to race out the door. But thank you very much, Alan. We look forward to it.
Hey, thanks. So it really wasn't all that hard. 12 days ago, I was in San Francisco, flew down to New Zealand, and an hour after arriving in Christchurch, stepped onto a 10-hour SOFIA mission. And then the next day got up and flew to Argentina, and then went down south 1,200 miles into Patagonia to where we were conducting an occultation operation of our KBO flyby target, and immediately switched to night schedule for 5 nights to observe, and then left the morning that we got the data and flew back here yesterday. So it's been a very easy 12 days. Yvonne, I wanted to thank you and congratulate you and all the members of CERVI, and particularly the CERVI PIs, for what NLSI has matured into. It is a shining example of some of the best in SMD. And thank you for your leadership. It's going to be sorely missed. And thank you, Greg, for your leadership as well and all the time that you've put into this. So I'm going to end up talking about some of the things that we all want to see, I think, that are involved in CERVI and the exploration of the moon and Mars and the near-Earth asteroids as well. But I'm going to start off very far away with a story about a mission to the very frontier of the solar system, New Horizons. It's traveled farther to make its exploration than any other mission in the history, not only of PI-led missions, but in the history of humankind. I know that for some of you who are in the audience who are very familiar with New Horizons, the first half of this talk is going to be probably a good time to be on your phone or whatever device you have. We have some co-Is that are here, some newer ones like Sylvia Protopapa and Alex Parker and Dan Britt, who've joined for the Kuiper Belt mission, some of the originals like Dale Cruikshank and Jeff Moore, Oliver White, who's one of our postdocs, and I'm sure there are others because I can't see everybody in the audience. So for those of you who already know the New Horizons story, tune in about 10 minutes because we're going to talk about the next 25 or 26 years. And we have a very high-tech device, so I can try not to turn around. I've got my phone set up like a rearview mirror, so I can try to see what slide I'm on, since no one thought of putting any monitors on the walls or anywhere else. But anyway, well, for those of us who worked on this project, some of us since the late 80s, and for most of us since 2001, 2,600 people, not just science team, but those who built the spacecraft, the instruments, the rocket, and who worked on this mission in different ways. The flyby of Pluto 2 summers ago was a defining event in our careers. For our parents' generation of planetary scientists, it was the highest prize that you could be a part of, and Jim Head will tell you that story, to be on something like Apollo, to be on the first missions to the moon, or for that matter, to be on Mariner, the first missions to Mars and Venus, or to be on Pioneer, first to Jupiter, or Voyager, to the giant planets. For our generation, there was only one real first mission left. It took a very long time to organize. And when we culminated that flyby on the morning of Bastille Day, the 14th of July, 2015, the emotion in the room was incredible. And the science that came out of it has been spectacular. But I think more importantly, that flyby represented something else. There are 2 New York Times covers there, and you can't read the dates, so I should tell you. The one on the right is the 16th of July, 1965, the morning after the first flyby of Mars by Mariner 4. And the one on the left is the 16th of July, 2015, 50 years later to the very day, with a flyby of Pluto, the other edge of the solar system. Across those 50 years, this country led the entire exploration of the solar system. We did not do it alone, but U.S. spacecraft were first to every planet in the solar system, from the closest to the farthest. And I think that's a testament not only to the planetary science community and our drive and our persistence and our ingenuity, our creativity, and the quality of the people that are in this community, but it's a testament to all of those administrations and all those Congresses over 5 decades that supported this enterprise. We swept across the entirety of our solar system, and New Horizons had the privilege of running the anchor leg in that relay and completing the first reconnaissance, the era of first reconnaissance of our solar system. And when we did it, the public response was phenomenal. This is a scene from the Johns Hopkins Applied Physics Lab on the morning of that flyby on the 14th of July, 2015. Thousands of people came to be there. And this was not a first time. Something similar happened during the Voyager flybys of the giant planets. But it had been a generation, and no one knew if the public was really that interested. As it turned out, 40% of the people alive in 2015 either weren't born when Voyager blazed its way across the giant planets in the middle of our solar system, or they were too young to remember it. And we used modern tools and social media and other forms of media very much, I think, to the agency's advantage, and achieved a tremendous, really a viral public participation in this mission. I am told by NASA headquarters that there were more than 1 billion visits to our website in a 48-hour period. That's pretty amazing. There were almost 500 newspapers that put the flyby on the cover above the fold the next day on every continent of the Earth, including the one and only newspaper in Antarctica. Countless magazine covers and social memes ranging from Big Bang Theory that wrote us into the script to getting the Google Doodle. People love exploration. They love what we do. When we present it correctly, when we're doing something really bold and first and showing someplace new or doing it in a new way, they eat it up. It's larger than life for us and for the public. And people from around the world watch this, not just in our country. You might ask, how did we get to do it? Well, it took a long time, 26 years, from the time that a few graduate students and a few young professors got together and say, you know, Voyager's wrapping up. Shouldn't we go do Pluto? Until we actually had data on the ground. It took a long time, very much like the aspirations in Survey to return humans to the moon, to expand our robotic presence there, and to explore Mars with humans and robots. We spent 14 years in the Washington Beltway in a maze of committees and approvals and 2 steps forward and 3 steps backward and 2 steps forward and 1 step backward, running around and around and around from 1989 until 2003 to unlock the funding to do this. It took a lot of persistence. There were 6 different Pluto missions that got started and then canceled. for different reasons. Some were poorly managed. Some people didn't care what they cost, thought that they could blow the cost up, and then they found out that they were shown the door. Some just had bad luck. Mars Observer exploded on the verge of a new start for New Horizons. And as a result, Dan Golden revectored all the money for an Outer Planets program into the birth of our current Mars exploration program. There were other reasons as well, and even New Horizons, after its selection, was canceled by the Bush administration less than 3 months after we were selected. It took a lot of persistence. And the same is true with our aspirations here for the exploration of the Moon and Mars by humans. And yet, finally, when a decadal survey ranked this at the top of the medium mission priority queue, the money was unlocked. And we competed for that. The New Horizons team did. There were 5 proposals. We were one of them back in 2001. And we were very fortunate to come out on top and have an opportunity to build the spacecraft called New Horizons. Now, when that AO came out, a lot of people thought that the winners would be losers because the AO specified that the budget that was available was only 20% of the budget for Voyager, and that the time that was available was impossible to build an Outer Planets spacecraft and get nuclear launch approval. It had never been done in less than 6 years, and that only once. Typically took 8 to 12 years. We were given 4 years and barely more money than a Discovery mission. After we won, it was a workaholic's dream. From 2002 to 2005, it was nights and weekends for 4 years and 2 months. And the people that worked on New Horizons never complained. They knew they were part of something very special, a chance not only to be first to a new type of object in the solar system and to a whole new region of the solar system, the Kuiper Belt, but also the chance of a lifetime to prove that you could do planetary exploration on a breakthrough schedule and budget. And so from the navigators to the mission operations folks, from the engineers to the scientists, from the management team across the board at every institution, every company, and every university, people just turned it on. They turned it on for 4 straight years. And as a result, we got to the launch pad on time and on budget, and actually accomplished nuclear launch approval in just 4 years. That required 42 state and federal agencies to approve our launch, including Governor Bush, the state of Florida. And then we flew for a decade across the solar system, flying at record speed and setting record crossing times across the orbits of Mars, Jupiter, and all the others, all the way out to Pluto. During the time that we were flying this mission, we operated on less than 10% the number of people, full-time equivalents, that Voyager had. Voyager, in extended mission, was 450 people. And New Horizons shed all those engineering teams and launch teams and all that, and it was really only about 50 belly buttons that flew the entire mission. Of course, we staffed up at the flyby, and we were about 200 strong, but it really was a very small team, and it showed that you could do this in whole new ways. Take a look at this picture. This is the best image of Pluto ever made before New Horizons. It was made by the Hubble Space Telescope. I was the PI of that program. In the early weeks of 2015, when we began our flyby, this was the best image of Pluto that had ever been made. Not much. And yet, by the middle of that year, by the summer, we could see Pluto, the binary, and the surrounding system of 4 small satellites in exquisite detail. We brought more scientific firepower to bear on the first reconnaissance of a new planet than had ever been done before, because we had 2000s era technology for our spectrometers, our in situ plasma instruments, and our cameras. And they dwarf the capabilities of what Voyager could do. Voyager had an infrared mapping spectrometer with precisely 1 pixel and a UV spectrometer with 2 pixels. Our infrared mapping spectrometer put 64,000 pixels on the target simultaneously and established a spectrum in the mid-infrared at every one, blanketing the entire surface of these bodies simultaneously in a matter of minutes. Our UV spectrometer, 32,000 pixels. And I could go on about the payload capabilities, but I don't have the time. The point is, Pluto turned out to be a spectacular place, and we now know more about it than we knew about Mars after the first 5 or probably 6 missions that flew by and orbited Mars. It is a scientific wonderland. Whether you're a glaciologist or an atmospheric scientist, whether you're interested in giant impacts or interested in the plasma interaction of atmospheres with the solar wind, whether you're interested in the size frequency distribution of planetesimals in the early solar system, the late heavy bombardment, tectonics, or interior oceans, or many other topics, there's something there for everyone. It is an absolutely spectacular system. And as this video, which Ashwan can start, will show you the range of geologic diversity across the surface of Pluto, made in these high-resolution images that are about 70 or 80 meters per pixel as we fly from Pluto's northern polar terrains down onto Sputnik Planitia, is spectacular. From layered terrains inside of craters to mountain blocks floating in a nitrogen sea, and then the largest glacier in the outer solar system, perhaps in the solar system altogether, Sputnik, convecting from some unknown heat source. This is a spectacular place, and I can tell you after a flyby that it's just all the more frustrating. We'll never get to the bottom of all this without an orbiter, and we need to go back. But that's not all. We've been busy writing papers and depositing the data in the Planetary data system. We've made the cover of Science and Nature several times. We've in total published about 60 papers in the refereed literature and given several hundred presentations about the results. And now we're at the beginning of a 5-year extended mission to explore the Kuiper Belt, its heliocentric environment, making telescopic observations of over 24 Kuiper Belt objects. And the centerpiece of this 5-year mission is a close flyby of a Kuiper Belt object with about 1,000 times the mass of Rosetta's comet, an object that's been in the cold, pristine Kuiper Belt for its entire history, something more pristine than anything we've ever seen before, which we will swoop down on at Christmas next year and make our closest approach on January 1st, 2019. Stay tuned. That took 26 years to carry out, to sell, to build, to fly, and then to reap the data from the Pluto system. We have some tremendous opportunities in the next 25 or 26 years. I'm very optimistic that we are on the verge of a flowering of the exploration of our solar system, unlike anything seen, perhaps even more than in the 1960s, in terms of the rate of change and exploration that we may see. And there are a number of reasons for that. One is the real birth of commercial spaceflight is something that will work to our advantage. And there are some reasons here. Commercial spaceflight is developing reusable launch vehicles. They're going to cut launch prices between a factor of 3 and 10. That's not all. Commercial services are talking about hosted payload missions, in which they get together a number of countries and go fly a mission to Mars or to the Moon or to asteroids or maybe further away destinations, shared by a number of countries. So instead of a US-dominated mission or a Russian-dominated mission or an ESA mission in which there's one instrument or a couple from other countries, countries banding together and each paying only 1/10 or 1/5 the cost. And that multiplies not only the capabilities that we have here, but that will multiply the number of countries that can afford to get involved in the exploration of the solar system. We're seeing the beginning of commercial lunar missions with companies like Moon Express. We're seeing the beginnings of discussions about asteroid resource recovery back to Earth for commercial purposes. And these are going to make a big difference over the next generation of students and planetary scientists for the kinds of jobs that are available. It's the kind of expansion that we see in terms of, for example, the mining industry, where geologists are employed and they do great research for commercial purposes. And then there's SpaceX and Elon and all those Teslas he's selling to fund a Mars program, to send humans to Mars. I have a lot of confidence in the commercial space industry. I think that there are going to be a lot of failures, just like there were in early aviation, but I also think there are going to be a lot of successes, and that we should embrace that, and we should find ways to leverage the government resources that we have with commercial resources. I'm also very excited about the fact that planetary science is becoming more and more international, that we're seeing more and more countries flying their own missions, from the Middle East going to Mars, to more than a dozen different countries that either have or are now building missions to fly to the moon. The Japanese at Venus, the Japanese at small bodies, the Europeans through ESA now reaching out well beyond the closest planets to explore the Jupiter system and to orbit a comet, and soon to orbit Mercury as well. On almost every continent of the Earth, planetary science missions are being formulated, built, or flown. And how about back here? We have a lot of demands. There are a lot of interesting things to do in the solar system. We need to explore the ice giants. It's long overdue. So is the further exploration of Venus. And so are the ocean worlds. The ocean worlds are an amazing scientific opportunity that may revolutionize our understanding of the evolution of life in the end. And there's so many of them. Who knew? When at the birth of the space age, it looked like the Earth was the only planet with an ocean, because we were biased by our preconceived notions that planets had to wear their oceans on the outside. Turns out most of them don't. The Earth is the oddball. There are so many oceans in our solar system waiting to be explored. As I said, Pluto begs for a return in a really competent orbiter mission. And the diversity of planets in the Kuiper Belt also begs for further reconnaissance with flyby missions. These are all important things to put on our plate and to do. And so is the return of humans to the moon. And then, after we learn how to do that, to send humans to Mars and further. It's 2017. This is the beginning of the 21st century. I think there's a growing awareness, not just in Washington, but in capitals around the world, that the 21st century is the century for humans to begin exploring all of our solar system. It's not a choice between the moon and Mars. It's an opportunity to do both and then to go on to the asteroids and to farther away destinations. But to do that, we're going to have to do things a little bit differently, maybe out of your comfort zone. We have to embrace the commercial opportunities. They are a way to leverage our resources. Some won't work out. Some will be dead ends. Some will be disappointments. So were 5 Pluto missions that never got off the drawing board. We have to go further than just embracing commercial opportunities, though. I think we have to advocate for a much larger planetary exploration budget in NASA. I don't think there's any reason in the world why we shouldn't double the planetary exploration budget to a level of about $4 billion a year. That would represent a 10% increase in the NASA budget. And I'm not talking about taking it out of any other part of NASA. I think the time is right in Washington to advocate for a larger NASA budget and a larger planetary exploration program. And if you couple that with commercial opportunities, then you just watch the pedal go to the metal with what we can do. We can afford to do the ice giants and Venus and Mars and the moon and humans and back to the Kuiper Belt and the ocean worlds, all of them. We don't have to choose between them at the rate of roughly 1 major enterprise per decade. And I also think it's time to start a discussion about moving the Planetary Science Division out of SMD and to be its own mission directorate with much more prominence and with much more exposure, where it can help the agency's larger goals of having humans exploring across our solar system. We are the vanguard in sending robots to explore all these places that humans should go so that we can do field work. And if we couple those commercial opportunities with a little bit larger NASA budget that allows us to double the planetary exploration program, and if it's the right thing to do to move the planetary division out onto its own, as Earth Science used to be its own mission directorate, so it's been done before, then I think we've really got something. We're really at the beginning of something great. This is my favorite picture from the flyby of Pluto. It's a true color image looking back at sunlight filtering through Pluto's atmosphere, made just a few hours after the flyby. There are lots of scientifically interesting details in this, but the reason it's my favorite image is because it can only be made from the far side of Pluto. I worked on that a long time, and so did a lot of other people. And just like the moonrise images from Apollo, it meant so much because you had to be there to get that image, to see the the Earthrise images, in which the Earth rose over the lunar limb. That astronauts had to actually be there to achieve that. You can only obtain an image like this from having completed the exploration of Pluto, by being on the far side where you can get to this geometry. This is a look-back image. We can look back over the last 50 years and be proud of all that we have done as a country, as a space agency, as a planetary science community. In the lifetime and careers of the people in this room, we have explored all the planets known at the birth of the space age. It's an amazing accomplishment. Carl Sagan wrote about it. He said that only once in human history would the solar system be opened up this way, and now it's done. So we are now at a turning point. What do we do next? We have an amazing opportunity in the next few decades to make these accomplishments look small. It's going to take a lot of work and a lot of persistence and a lot of ingenuity and people who won't take no for an answer. The exploration of Pluto is no different, and we got it done. I think we should take the next step. Thank you very much. Yvonne, I'm sorry for running long.
Oh, that's okay. We
Thanks.
enjoyed every moment of it. Thank you so much, Alan. And I wish we could open this up for questions, but his wife will kill me if I don't get him home tonight. He's got to get to the airport.
Thanks again.
Thank you so much. Bye-bye. Let's thank him again. What